quadratic formula. First of all, if you pull out that blue formula page, guess what's on there? Quadratic formula. So again, why this one is really good to have memorized, just because you can use it so often, and just in, it can come up in various problems outside of this lesson. Okay, so quadratic formula is a good one to know, to have memorized. On the test, you will have it in front of you. It's how do I use it? Okay, knowing how to use it. So quadratic formula, in my book, is the backup plan that always works. It will solve any quadratic equation, no matter what. Okay, so x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. There's your quadratic formula. And of course, our ABCs are based on the standard form equation of ax squared plus bx plus c equals 0. So before you snag your ABCs, your equation has to equal 0, of course. Okay? So, let's jump right in. 3x squared minus 4x minus 9 equals 0. You could try to factor. Okay? My guess is it's not going to factor. And, yeah, looking at the answer, it doesn't factor. So, but if you tried this, like product of AC or slip inside, you'd have to have something that multiplies to be negative 27 and adds to be negative 4. And guess what? Those numbers don't exist. So, completing the square could be done. It wouldn't be pretty numbers here. So quadratic formula is our best bet. So let's practice. Do you remember quadratic formula at all from Algebra 1?
Yeah.
A little?
It looks familiar.
So once we get into it, maybe it'll come back to you?
No.
You should have had it. You had it in Algebra 1. Whether you remember it, always a different story, right? Okay. Not that you have to, but I'm going to. What are my ABCs? What is A? 3, because it's in front of x squared. What is B?
4. Negative 4.
Negative 4, because it's in front of x. And what is C? Negative 9, because it's a constant at the end. And note, my equation does already equal 0. So, we're going to fill in that quadratic formula and work on taking the steps. X equals negative b. Okay, so negative b is going to be the negative of negative 4, which, yes, I agree is 4. I would just go straight to 4. Plus or minus the square root of b squared. When I write that b squared, I'm going to put negative 4 squared in parentheses, minus 4 times a, which is 3, times c, which is negative 9. All over 2a, so 2 times 3. I would always encourage you to write down that 2 times 3. I've seen some people try and skip it and think, oh, I'll put it in at the end. Ultimately, they forget to put it in. So, okay. Work on some cleanup. Negative 4, we already declared is 4. Under the radical, under that square root sign, what needs done?
Negative 4 squared is 16.
Okay, negative 4 squared, negative 4 times negative 4 is 16, always going to be a positive. Okay, some combination of negative 12 times 3 times negative 9. I heard negative 12 times negative 9, which is going to be positive. Okay. So my guess was 108. So all over 6. So under that radical, do your squaring, do your multiplying of 4ac, and then I would clean it up. What is 16 plus 108? 4 plus or minus the square root of 124 all over 6. Okay. Options.
Take the square.
Okay, so take the square root of 124, which we might want calculators by our side today. Not that we're going the decimal route, but for where we're going with this. What does your calculator tell you the square root of 124 is?
11.5.
Okay, a decimal, right?
0.13.
Okay. Now, we're not going decimal answers today. Not that we couldn't if we needed to. But we're not going decimals. However, based on what I saw happen to someone yesterday in Savas, they're going to say, well, this is equivalent to the correct form. It is not the final answer. What do we know about 124?
Be divided by 6.
No.
So think about what perfect square could divide into 124. This is why I said have the calculator, right?
16.
What?
16.
The 16?
No.
I don't know. I didn't think it went that big.
No.
No, but I'm not looking for the closest square root possible. I'm not estimating. I'm looking for what perfect square divides into this. So there'll be a perfect square times a number.
That's a great question.
Does 4 divide into 124?
Yeah.
4 times what? 4 times 31. Why would I pick 4 times 31?
Because 4 is perfect.
The square root of 4 is
2.
2. What's the square root of 31? A decimal, so we leave it as 2 square root of 31. We reviewed this a little bit the other day, yes? I kind of find it odd they throw this in and expect you to do it, even though we teach it. I officially teach this in big scale later on, so. But, okay, so let's look at what this does to our answer. X equals 4 plus or minus 2 square root of 31 all over 6.
It's the same thing as 4 square root negative 124.
Right, I've just rewritten it. We're still keeping the 4 and the 6. We just changed the square root of 124 to be 2 square root of 31. Savas again would say, well, this is equivalent to your final answer. It is not simplified enough. Or however Savas gives that lovely no.
Wrong.
Like, I'm still going to count wrong is what they're saying. What do you notice here? There's 3 terms. What do all 3 terms do? They all divide by 2, yes? So you need to simplify this fraction. There's 3 terms. There's the 4, the 2 square root of 31, and the 6. The number outside the square root of 31 is what matters. Everything divides by 2. So if everything divides by 2, 4 divided by 2 is 2, plus or minus 2 square root of 31 divided by 2, just square root of 31, and 6 divided by 2, 3. Savas should like that as an answer. I like that as an answer. I mean, I use Savas as the example, but in all honesty, I'm not going to give you full credit if you don't simplify. The difference is I give partial credit. Okay?
So what do we need to do?
Solving quadratic equations,
Yeah.
which is a lot. There's a lot that we do with solving quadratic equations.
Why do I need to solve
That is a very good question.
Oh my gosh. Taxes.
I don't know. I've never done taxes.
Me either. I just get somebody to do them for me.
Okay, guys.
Never give the
Refocus. Refocus. Now, one thing. Let's see, where does it come up? Okay. There is, I forgot to look and see. First of all, how many solutions do I have?
2.
2, yes? Because there's a plus and there's a minus option, right? So I have 2 solutions. Are they real or imaginary?
Real?
Real because there's no, what would make them imaginary?
Negative. And
If there was a negative in the square root, or in other words, an I in our answer, right? Is there an I in my answer?
No.
Okay, so there's two real answers. Now, the other question is, do you remember the difference between rational and irrational?
Yeah. 50-50.
Rational.
I never know the difference.
Rational either repeats or ends, or irrational never ends. Never repeats.
Okay.
Yeah.
That was one of those things I just never learned.
Okay, and I always say rational can be expressed as a fraction. And here's the deal, it's all going to come down to the square root. Can we take the square root of 31? No, it's a big, long, never-ending decimal, right? It doesn't repeat, it doesn't end, so that makes it irrational. Okay, so when you have the square root you can't do, it's irrational. So I'm assuming this comes up in homework because I forgot. I went through the homework, but I didn't pay attention to this piece. The fact that there are two real irrational solutions. Okay? And again, if I have that written in my notes, I knew I wrote it in there for a reason. I just don't remember what reason. So this is two real irrational solutions. If nothing else, I'm trying to help you with remembering the different types of numbers.
Will they
Okay.
ask this on Sabbath?
What?
Will they ask?
I think so.
Will
I-
multiple choice?
I don't, this is, I forgot to look.
Sure.
I forgot about it. You wouldn't, it would, yeah, you definitely wouldn't be typing. It would be more multiple choice in that sense, but, okay. Ready to try B? Okay. Let's start off with ABCs. Again, not that you have to write them out, but,
Would you want to add the 27 over first?
do we need to add our 27 over?
Yeah.
Yeah. Okay. In order to get our ABCs, and I've already gotten there because no one caught it. In order to get our ABCs, this equation has to equal 0. In order to make it equal 0, you need to add 27. So now, when I rewrite this, it's going to be x squared minus 9x plus 27 equals 0. Now what are my ABCs?
1, -9, 27.
Okay. A is 1 in front of x squared. B is -9. It's the coefficient on x. And C is positive 27 because it's a constant being added at the end. Okay. X equals, there we go. Negative B. What do you think negative B?
9.
The negative of -9, or the opposite of -9 is 9. Plus or minus the square root of B squared, -9 squared, minus 4 times A times C. So times 1 times 27 all over
2 times 1.
2A, 2 times 1, or in other words 2. Okay, some cleanup. 9 plus or minus, what's going on under that radical? Okay, -9 squared is 81. Minus 4 times 1 times 27. So minus 4 times 27,
68. -68.
108.
108.
here's my thing, guys. 425s is 100. And this is 427, so I know it's more than 100. All over 2. And actually, I probably should have just gone ahead and done the simplification there, but I didn't. 9 plus or minus. What do you know about 81 minus 108?
It's a negative.
It's a negative. Negative what?
27.
27. All over 2. So I have 9 plus or minus the square root of negative 27 all over 2.
9 plus or minus the square root of 27i.
Partially. That's half of it. So she says it's going to be square root of 27 times an I. I agree, but I need more.
Square root of 9. Square root of 9.
Square root of negative 27. First of all, there's a negative, yes? So I pulled that square root of negative 1 out. The square root of negative 1 is going to be I. And then, why did I say I liked Mikhaili the I, but I didn't quite like the 27? Because 9's a perfect square, yes?
Yep.
The square root of 9 is 3. And then you have the leftover square root of 3, which just stays square root of 3. You don't have to do this side note piece, but I figure right now we kind of need it. So put this all together, and I would write this as 3i square root of 3. Okay, so what's that mean my answer is looking like?
9 plus or minus 3i square root of 3 over 2.
Okay, 9 plus or minus 3i square root of 3 all over 2.
Final answer.
Is it the final answer?
Yes.
Yes.
You can't divide.
And here's the deal. Do 9, 3, and 2 all divide by something
No.
other than 1? No. So 9 plus or minus 3i square root of 3 is final answer. Now, how many solutions do we have?
2.
2. Imagine.
Are they real?
No.
They're not real because there is an I. I have the vocabulary I have written here is non-real. I get imaginary. And because they are imaginary, I don't know if you guys remember when I taught 2-4 last week, those A plus BI form numbers were called complex numbers. Like, yes, we call them imaginary numbers, but the more official, broader category is that they are complex numbers. So we have 2 non-real complex solutions. So 2 non-real complex solutions. Okay, so far you've seen irrational. You've seen non-real or imaginary. Okay. Ready for C? Do you know enough to stay ahead of me on C? Maybe get all the way to the end?
Try.
Okay. What about your ABCs?
2.
Are they there already?
Yes.
Okay. My equation already equals 0. A is 2, B is negative 11, and C is 12. Okay. You're filling in your equation, right? What about negative B or the opposite of B? 11 plus or minus the square root B squared minus 4AC all over 2A. So under my square root, it was negative 11 squared minus 4 times 2 times 12 all over 2 times 2. Okay, what's going on in that radical? Yeah, you probably want a calculator by your side today, don't you? Negative 11 squared is? Yep, 121. Minus 4 times 2 times 12. 8 times 12 being 96. All over 4. What is 121 minus 96? 25? Oh, I like that. All over 4. Why do I like 25? Perfect square. Square root of 25 is 5. So 11 plus or minus 5 all over 4. What do we do? Do we stop?
Yes. No.
You can get,
Well, your answer is correct. It is not in the most simple form. Or
you can just get
Alright,
the 2 answers.
could we actually just keep going? Can you add 11 plus 5? And can you subtract 11 and 5? Yeah. There's no square root. There's no I on that second piece. Keep going. I want 2 answers. In other words, I'm going to come up with what is 11 plus 5 divided by 4 and what is 11 minus 5 divided by 4. So 11 plus 5 is 16. 16 divided by 4 is 4. 11 minus 5 is 6. 6 divided by 4. It's a decimal 1.5. I would leave it. I could see them saying we don't want decimals. We want integers or fractions. So if that's the case, 6 over 4 reduces to 3 over 2. Divide top and bottom by 2. So my solutions are 4 and 3/2. So it would be 4 comma 3/2 is probably how you would enter it on Sophos.
That's more my style.
You like it when it comes out nice, even if there is still a fraction answer. Okay? How many solutions? 2. Real or not real?
Not real. It's a decimal fraction.
Fractions are real.
Everything's real other than unless it has an imaginary. So it's real. There's 2 non-real, or dang it, 2 real. Rational or irrational?
Rational.
Rational. Irrational was the one up above where I can't simplify that square root. That's irrational. These are rational because I could simplify the square root. I got answers that can go to fractions. So this is 2 real rational solutions. Okay. Try D.
Add your 6.
Move that minus 6x over before you start. If it's a minus 6x, we're going to add 6x. How should I write the left side of the equation now? Good. X squared plus 6x plus 9 equals 0 is in your best interest at least, right? Okay. Because you guys like to see ABC order, don't you? You don't want to have to think extra hard about that. You want to see the order right as is. So, with that in mind, A is 1, B is the coefficient of X, that is 6, and C is 9. Okay? Are you already working on quadratic formula without me? You should be. Okay. Negative B. What's negative B going to be here? I don't know. We actually get to put negative 6. Plus or minus the square root, B squared, So 6 squared minus 4 times A times C, all over 2A.
We do got an issue.
We got an issue?
That's nice.
It's a good thing.
It's a very nice.
Okay.
What's the square root of 0? 0. So there's nothing.
Okay, let's get caught up to the issue. 6 squared is 36 minus 4 times 1 times 9, 36, all over 2. So negative 6 plus or minus the square root of 0, all over 2.
Just get rid of it.
What is the square root of 0? It's 0.
So
Okay.
3 negative 3.
So we have negative 6 plus or minus 0 all over 2,
Oh, wait.
which the 0, if you add 0 or subtract 0, it's the same, right? So this is just negative 6 over 2, which is negative 3.
One real rational.
I'm going to throw one other piece in there, but yes. Okay, so there is one solution here, yes. And officially, even though we see one solution, technically, there were 2 solutions that were the same. Technically, if we do the math out, we got negative 3 twice. Okay, so I have this one listed as one real repeated solution. Okay, something that we talk about sometimes with quadratics, but we have, I agree, 1, and it is real, there's no i's. Repeated solution. And again, it's repeated because if you add the 0 and you subtract the 0, we technically are getting 2 answers. Okay?
Good work today.
Huh?
All right, good work today.
We're still going.
For how much more?
Just,
I don't know.
just the next proper.
We're going as far as I want to go.
We get the back page
Well-
for tomorrow.
The bells only once you get.
Okay. Let's talk about Dion.
Dismiss you. I
Dion.
do.
Dion. Yep.
Like prime time?
Like the Dion that throws a ball into the air.
Yeah.
Dion too.
Okay. So the Dion throws a ball into the air. The height h of the ball in meters at time t seconds is modeled by this function. When will the ball hit the ground?
About
Why is he
Couple
throwing it?
seconds.
Why is he throwing it to the ground? Why is he not have the catch it?
Well, it's gonna.
Well,
Oh, I was gonna say everything hits the ground eventually, but
know how long it takes.
Then I can just go chase it.
okay.
Jesus.
Refocus. What are we doing here?
Quadratic.
Quadratic formula. The question though is when does the ball hit the ground? So the ground is 0, yes? So that means we want to know when does the height equal 0. And so if we're asking when the height equals 0, then yes, you are setting your equation equal to 0 officially. So negative 5t squared plus t plus 4 equals 0. Now, did you want your ABCs?
Sure.
What's A? Negative 5. What's B? The invisible 1. And what's C? 4. Now, instead of saying x equals, I'm actually going to say t equals because my variable is t. Not that that makes a huge issue to what you write, but official form. Negative b, negative 1 plus or minus the square root of b squared, 1 squared, minus 4 times a times c all over 2a. negative 1 plus or minus, what is 1 squared? 1 minus 4 times minus 5 times positive 4. 80? Is that what you said?
Positive.
Yep. Minus times minus is going to make it plus. It is going to be 80. All over negative 10. So negative 1 plus or minus the square root of 81 all over negative 10. What do we know about the square root of 81? It's 9. Negative 1 plus or minus 9 all over negative 10. Do I stop here? Nope. There's no square roots. We actually need to get our answers. Negative 1 plus 9 divided by negative 10 and negative 1 minus 9 divided by negative 10. Negative 1 plus 9 is 8 over negative 10. If I reduce that, it's negative 4/5. Or you could say the decimal negative 0.8. Negative 1 minus 9, negative 10 divided by negative 10, 1. So what?
Use 1 because but.
Okay. The question was, when will the ball hit the ground?
After 1 second?
Is the ball going to hit the ground at a negative time? No.
He's not good at throwing.
I don't know. Maybe his line didn't block for him very well and he had to throw it.
Why is always mine full?
Yeah.
What
Well, if the guy didn't run his route.
Yeah, what if we got him running?
Maybe that's the case.
Yeah.
What if his hand slipped? What if they?
Maybe no one got open.
What if we
that
blocked
better?
5 and they rushed 7?
Okay, so
Just break. You just got
when will the ball hit the ground? At t equals 1 second.
Alright, now we're done.
Please.
We only have like a couple minutes.
Well, we gotta do the.
Okay.
1 astral or 2 back.
No, we don't have to on that one. Okay.
Oh, yeah. That's not what
The back side of this.
Yeah, I think we should get for a rainy day. Also.
If you
Okay.
teach it today, we'll forget it.
The back side of this, okay, talks about something called the discriminant. Okay? When we talk about something called the discriminant in math, we are specifically talking about b squared minus 4ac. Okay? Now, what do you recognize about b squared minus 4ac?
It's part of the equation.
Yeah, that's what was just under the radical, yes? And that piece that's under the radical will help us know how many solutions there are and what type of solutions there are. Okay, so we are talking a little bit about types of solutions. If you get a b squared minus 4ac value that is greater than 0. When I say greater than 0 is another way of saying positive, right? So if my discriminant is positive, there's going to be 2 real solutions. Meaning, this parabola, remember our solutions are where the graph crosses the x-axis. So my solutions are going to be the fact that the parabola is going to cross the x-axis twice. Now, that's if b squared minus 4ac is a positive number. Something that you may or may not be able to take a square root of, but there's not going to be any i's. Okay? The third option is if b squared minus 4ac equals, yes, the second. Okay, b squared minus 4ac equals 0. So this would mean if you get 0 under the radical. We just had that happen, didn't we? 2 examples ago. And when we got b squared minus 4ac, there was just one solution when it was equaling 0, wasn't it? And that's just saying that it crosses the x-axis once, or it touches the x-axis once. And then the third option is going to be if b squared minus 4ac is less than 0. Less than 0 means negative. And here's the idea, guys. If b squared minus 4ac is negative, my parabola never touches the x-axis. It's either all the way above it or all the way below it. So it's never going to touch the x-axis, and that means we're not going to have any real solutions. This is where imaginary solutions come into play. We're going to have 2 non-real solutions. Okay? So, with that in mind, there are times where we don't have to know the actual solutions to answer the question. We just have to know the types of solutions. Okay? So what we'll be working on is figuring out, based on the discriminant, what types of solutions are there. So on the front side, I was kind of getting you guys into what types of solutions there are, but we're actually finding the solutions. Here it will be, okay, what's the discriminant and what type of solutions are there?
Leon's coming back.
Dion is coming back tomorrow. So we will work on these discriminant problems tomorrow. 2.5 is due today. Make sure you get that done. Okay. Tomorrow we'll do the discriminant problems, which shouldn't take us as long. And yes, Dion comes back again tomorrow.
He's terrible at this problem.